Hi friends, here in this video I'll be explaining the problem on epicyclic gear train. So let's get started. Now here is the question in front of us. It is given for an epicyclic gear train as shown in figure. The diagram is given, and in this diagram somewhat we can say that there is an annular wheel A, which means it is an internal gear, because annular wheel whenever they have given, it means annular means internal, so it is internal gear having number of teeth as 150. This internal gear is in mesh with gear B, whose number of teeth is 25. Then it is in turn mesh with gear C, whose number of teeth is 30. And then gear D, whose number of teeth is 40. Now I'll read the question which is given. Meshing with annular wheel A is wheel B. So A is in mesh with B as I had explained. Then wheel B, which drives wheel D through an idle wheel C. So B is driving D, which is here, with the help of an idle wheel, which is wheel C or gear C. Then wheels B and C are carried on arm E. So here we have an arm E which is connecting B and D. Then which revolves at 100 rpm, or we can say which revolves clockwise at 100 rpm. So the speed of arm E is given, that it is revolving in a clockwise sense about the axis of A and D. So moving about this axis, which is the axis of annular wheel A and gear D. If the wheel B and D have 25 and 40 teeth respectively, so the number of teeth for B and D are given. Find the number of teeth on gear C and its sense of rotation. So we have to find the number of teeth, and here I have written that the number of teeth is 30. So this I would be proving that how this 30 comes from. So first thing is to find the number of teeth on gear C, first question, and its sense of rotation. So we have to find the speed of gear C, that would be also indicating the sense of rotation. So how this 30 comes from, that is the part of the solution. So starting with the solution part. So the first thing is calculation for number of teeth on wheel C. Now how to calculate that? From the geometry of this figure, I can say that the radius of wheel A, which is this outer wheel, this radius is made up of the diameter of wheel B, diameter of wheel C, and radius of wheel D. So writing them in the form of an equation, from the geometry of the given figure, the radius of annular wheel A is equal to so here is the condition that radius of wheel A is made up of diameter of B plus diameter of C plus radius of D. Then radius is diameter by 2 for A. B I am keeping as it is. That is, the next step is to keep all the radiuses in the form of diameter. Then here I would be replacing the diameter, because since module for the gears which are in mesh is given by module M is equal to capital D by T. This D indicates the pitch circle diameter, which is there, we can say, in the given figure. It is the pitch circle diameter. So from this I can say that diameter is module into number of teeth. So here I would be replacing all the diameters with module into number of teeth for the respective gears. Therefore, now remember this, whenever two gears are in mesh, if their module are same, then only they would be in mesh. So we can say that module is common. So on the left hand side we have module, on the right hand side m would be taken common, and both the m would be cancelled out. So module gets cancelled from all the sides. So what remains here is, we have TA by 2. I'll bring TB onto the other side, so it is minus TB. Similarly, TD by 2 onto the other side, that becomes negative, and keeping T suffix C, that is the number of teeth on wheel C on one side, because that is what we have to find out. Therefore, TA is given as 150, number of teeth on annular. The number of teeth on B is 25 given. Number of teeth on D is 40. So when we calculate here, the answer comes out to be 30. That's the first answer. That is, I found out the number of teeth on gear C and it is 30. So first question has been answered. Now we have to find the speed of gear C and its sense of rotation. For that, in an epicyclic gear train, we have to solve it by using the tabular method. So that tabular method I am going to show it here. So now in case of this tabular method, the first column is for the number of steps. Second, it is operation, that is whatever operations or revolutions we are giving. Then we have revolution of the elements, which is denoted by capital N. It would be in terms of RPM. So starting the first column in the revolution with arm E, because at first the assumption would be arm E would be fixed. This arm E has to be fixed. Next, here how the motion I am starting is, keeping E as fixed, first D would be rotated, then D is in mesh with C, so the order is arm E is fixed, gear D would be rotated, D would be rotating gear C, so next there is gear C, gear C is in mesh with gear B, so it would be rotating gear B, then at last the annular is rotated with the help of gear B, so we have gear A or annular at the last end of the column. Now, how to start these steps? The first one would be, so the first operation is keep the arm fixed and give +1 revolution to gear D. So arm E is fixed, its motion is 0, gear D is given +1 revolution. Then I have to find the speed of gear C. For that I would be using the concept of velocity ratio and just explaining that concept, how to get the speed of gear C. For that, when we are giving +1 revolution to D, it means D is rotating in a clockwise sense, because as per our convention, clockwise rotation we are going to treat them as positive, anti-clockwise as negative. Now D and C, they are external gears. So in case of external gears, if one gear is rotating in a clockwise manner, other one would be rotating in an anti-clockwise sense. So the direction is opposite for C and D, the velocity ratio would be written that D is the driver and C is driven. So it would be that since velocity ratio is equal to speed of driven, which is in the numerator, here driven is C and the driving gear is D, so NC upon ND, that is in inverse proportion, that is speed is in inverse proportion to the number of teeth for the gears. So here if we have NC, in the numerator we are going to have TD, that is the number of teeth on wheel D. Similarly, if we have ND here, speed of gear D, so number of teeth for gear C, and negative sign because since C and D are external gears, that is why we have a negative sign here, because the direction of rotation is opposite. Therefore, since we have given +1 revolution to ND, NC would be, ND would be multiplied giving +1 revolution here, so that would be -1, so 1 into TD by TC. Therefore speed of C is minus TD by TC. Once this speed is known, I can put this into the table. Speed of gear C minus TD by TC. Then for gear B, I am going to find the speed in a similar manner, like since speed of, now as we can see B and C, they are in mesh and they are also external gears. For B, C is the driving gear, so B becomes the driven gear. So speed of driven, which is B, upon speed of driver, that is C, is equal to the number of teeth on wheel C upon the number of teeth on wheel B, since they are inversely proportional. And here also I am introducing a negative sign because C and B are also external gears, so I am putting the negative sign because of the opposite nature of rotation. So when C rotates anti-clockwise, B would be rotating in a clockwise sense. Therefore N suffix C would be multiplied here. Now here I have the value of N suffix C, which is negative, so this is minus, putting the value here, minus TD by TC. So therefore negative and negative, this it becomes positive, and here TC and TC would be cancelled, so we are left with TD by TB. So that is the speed for gear B in terms of RPM, both are in RPM. So into the table for B, it is TD by TB. Then at last we have gear A, or we can say the annular. It is in contact with B. So B is the driving gear and A is the driven gear. So the velocity ratio would be, I'll just show it here, that the velocity ratio, since NA, it is the driven gear, upon NB, the driving gear, speed is equal to number of teeth on B upon number of teeth on A. Now their sense of rotation is same, like B is rotating clockwise, so even A would be rotating in a clockwise manner. Since the direction of rotation is same, we have to put it positive, that is no need to add negative sign here. Negative sign would be added only in case of external gears, as we have seen, because of the opposite nature of rotation. Here the nature of rotation is same, so we are putting just the positive sign. So finally NA would be equal to NB into TB by TA, and NB value has just been calculated, it is TD by TB, So T suffix B or number of teeth on B gets cancelled, and finally what remains is speed of A, NA, is equal to TD by TA in terms of RPM. So into the table I'll put this value for A, which is speed of A, TD by TA. Now once all the speeds have been calculated for the respective gears, the next operation or the next step is multiplying by m, which is small m, RPM throughout. So when m gets multiplied with 0, this is 0. Here we have plus m. This becomes minus m into TD upon TC. This is m into TD by TB, and here m into TD upon TA. Next, adding plus n revolution to all elements. So when I add here, this becomes small n plus 0, that is n. Here we have m plus n. And finally the total motion. So this last row is the total motion. So for arm E it is n, for D m plus n, so these are the total motions. And for arm E, this is the speed which would be in terms of RPM. For D, similarly for C, B and A. So in case of the problem further, these speeds would be used. And now I'll read the question again, what we have to find out. It was given into the problem, meshing with annular wheel A is wheel B which drives wheel D through an idle wheel C. D and B wheel D being concentric with wheel A. And it was also given in the problem that the annular is fixed, and so wheels B and C are carried on arm E, which revolves on 100 RPM clockwise direction. So the two conditions which I am going to use here is keeping the annular as fixed, then arm E is rotating with 100 RPM in clockwise sense in order to find the speed of gear C. So the next calculation would be calculation for speed of gear C, and for that the condition is that since speed of gear A or the annular is equal to 0, and why it is 0? Because the annular is fixed. So therefore from the final table we can say that gear A, its speed is this, which is m into TD upon TA plus n. So I'll write it that therefore, and now this term is equal to 0 because that is the annular which is fixed. M, TD value, number of teeth on wheel D, it is 40. Number of teeth on A, that is 150 plus n is equal to 0. So this I would be keeping as the first equation. Then for the second equation, the second condition which I am going to use here is, they have said that arm E is rotating in clockwise sense with 100 RPM. So speed of arm E 100 RPM in clockwise manner, so positive, and from the table the speed of E is arm E, it is small n. So therefore from the table, small n is equal to the speed of arm E, and that is 100 rpm. So this is the value for small n. Now putting this value, that is small n, in equation 1. So when I put this value, here we have 40 upon 150 into m plus small n, which is 100, is equal to 0. Now this 100, when it shifts onto the other side, it would be minus 100 into 150 divided by 40. So from this I'll get the value of small m, and my answer is minus 375 rpm. And once m and n are known, the question is to find the speed of gear C. Gear C, its speed is here into the table in the total motion minus mtd by tc plus small n. I am going to write this value. So therefore n suffix c is already there is minus, and small m is minus 375. TD upon TC. TD was 40. TC value was 30. We had calculated this. Small n is 100, that is plus. So finally, speed of gear C comes out to be 600 rpm, and that too a positive value. This small n is 100. 600 rpm positive value, it means gear C would be rotating in a clockwise sense as per the given conditions. We have found out the speed of gear C, also its number of teeth as said in the question, and even its sense of rotation, that is finally when the conditions are given. In that case, by using the conditions, that is keeping the annular as fixed and rotating arm E in a clockwise manner with a speed of 100 rpm as mentioned in the question, the speed of C is 600 rpm clockwise. So that completes the problem. At the end, if you'll find my videos helpful, you can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.